All right, now here's the rest of the setup. What we have is some refrigerator magnets, those rectangular magnets that you might be able to get in a hardware store, craft store. I have them duct taped onto a little piece of plywood as a wooden base. I have a couple holes drilled, and then I have these were large, very large office paper clips that I bent and put in the holes here like this, so they will be able to carry electricity up, and these will act as my brushes. Well, actually, these will act as my my brushes, and then my split ring commutator again is the wire sticking out on the axle here, which contains the loops. So now if I stick this in here, see if I can get it in between the wire or the paper clips like that, then of course when loops in this orientation, current is, if these are at different polarity, different voltages, when the bottom part of the commutator for the one loop makes contact, current will flow through it. The loop will be in this orientation. You'll notice the wires down here would be fairly close to the magnet, and they will get a push either that way or this way, depending on the direction of the current flow. And then if there's enough of a push, it will flip around and will make contact in the other loop, and I'll get another push. So every half turn, I'm going to get a push here, right? Now, this will run with a flash, a couple flashlight batteries. Depends how many loops you have, how low your friction is, so on and so forth. I've been using this for quite some time, and so my electrodes are starting to wear down a little bit. And I didn't want there to leave any doubt as to the functioning of the motor. So what I'm going to do is I'm going to hook up a 12-volt battery, which is like a car battery here, and that will give us plenty of voltage. Okay, so I'm going to stick probably more voltage than we really need, but always better to use a little more power to show a demonstration, I think, than not enough. And so on that side, I'm connecting the black lead, which is the negative lead, essentially over here, and I'll connect the positive lead up on this side, right, like this. And so now when I flip the switch, we should apply voltage to this crude little motor, and you'll be able to see that it runs. So first, again, the switch is on. However, I may have to, make contact first for it to start to turn. So there you see the motor turning pretty dramatically. It's actually turning this way so that the top is coming towards you. If I take these leads and I reverse them, you'll notice that the motor will now run with the top going away from you. So DC motors are reversible, right, by changing the polarity of the current through them. You'll notice some sparks on here, even though we're only using 12 volts. And part of that is caused by the inductance of the loops of wire. And of course, they increase the voltage. They cause a voltage spike when they connect and disconnect. And we'll talk more about that in our chapter on electromagnetic induction. But there you go. There's a simple motor. You can see that it doesn't take much to make a motor run. All right, some magnets, some kind of support for brushes, and then the split ring commutator with the loops. To make the motor more efficient, we could add an iron core in here and add extra loops at different angles, add more magnets around it, and we could get much more torque and much more speed out of the motor probably as well.